Sum and difference of powers. Now, as I say, I did mention this before back in calculus, where we were deriving the formula for how do we differentiate x to the power of n. You might remember, and I had to come up with this formula to do it. And the basic idea is, well, we know the difference of two squares, a squared minus b squared, a minus b, a plus b. And we also this year saw the difference of two cubes, a cubed minus b cubed. Again, it started off with a minus b, but then it went a squared plus ab plus b squared. Now that pattern continues. So it doesn't matter what the power is, it'll always start with a minus b. And then in the second parentheses, we just go a, take one off the power, then b, add one to the power. So it starts with a to the n minus 1, then the next term, take one off the power, a to the n minus 2, add one to the power of b, b. So the two powers should always add up to be n minus 1. So that's the generalization of our difference of two cubes, difference of two squares. Now when it comes to the sum, it is true sort of. And the sort of is this little condition. It only works for odd numbers, for odd powers. That's why we have a formula for the sum of two cubes, but we don't have a formula like this for the sum of two squares. You remember when we did sum of two squares back in sum and product of roots and questions like that, we said, a squared plus b squared was a plus b all squared, but then we had minus 2ab. So there wasn't a nice, neat factorization for it. So for the sum one, we have to have odd. So if I wanted to factorize x to the power of 5 minus 32, 32 is of course 2 to the power of 5. I'm not saying you would write that line down, that's what we're thinking. We're looking at 32 is 2 to the power of 5. So it starts with x minus 2. Powers of x then start at the power of 4. Then next one, powers of 2 go up by 1, so I now have 2 to the power of 1. Power of x goes down by 1. I got x cubed. Next term, power of 2 goes up by 1, 2 squared. Power of x goes down by 1, x squared. Power of 2 goes up by 1, I've now got 2 cubed, 8. Power of x goes down by 1, x to the power of 1. And we get to our last term. Power of 2 goes up by 1, 2 to the power of 4, 16. Power of x goes down by 1, x to the power of 0 is of course just 1. And so there's our factorization. Now it is true, and we'll see this when we look at polynomials, that all polynomials can be factorized down to be a mixture of quadratic and linear functions. So it is actually possible to factorize that second parenthesis. We're not going to worry about that for now. In polynomials, we'll see techniques to do that. There we go. 6,